Okay, you are live.
Okay, so hi everybody, or good afternoon, good evening, good morning. I'm not quite sure which location are you in. So this is Hyperledger, and then I'm gonna hear on this meetup basically a speech on tokenization on enterprise ledger, which is, I mean, not so much popular topic at the moment, but it might be getting into hype, going into hype, perhaps in a couple of months or even a couple of years. So it's getting more and more important. So this is Hyperledger, if you're coincidentally not familiar with the stuff. So it's basically an open community, mostly for consortium blockchains. There's one exception as well, that's Hyperledger Besu, which have some public parts as well. But basically, there's not much like, cryptocurrency trade here usually, and everything even by the Linux Foundation. So it's just free of charge, open source, and community basis. So everybody is just welcome to contribute or share any knowledge or anything. So the agenda for today is something different. I've just built up my presentation step by step. So first, I will talk a little bit about blockchain evolution. I'm not gonna go very deep into the details, so I don't start from Bitcoin very strongly, and it's just gonna be one slide. Then I speak a little bit about tokenization generally, some example tokenization use cases as well. Then we see token standards very briefly, something which is token taxonomy. It's not so much well known in the public area or public space. And then I'm going to give some, I have one slide on tokens, how tokens look like on Hyperledger Besu, on Hyperledger Fabric. These are Hyperledger products or platforms. I got one slide as well on R3 Corda and tokens, which is not Hyperledger, but basically it's a consortium distributed ledger platform, so it might be interesting. I got one slide on interoperability, especially on tokens. And last but not least, I'm going to have a demonstration. I will show how Hyperledger Fabric implements one token. It implements several, there are examples for several tokens. I will show just one ERC20 token. We don't have the time to go very deep into the details of other tokens as well. Altogether, I think it's going to be like 1 hour. And at the end, we can have some time for general discussion or, sharing knowledge, sharing experience or any kind of stuffs. So that's the questions and answers at the end. So I would suggest, I would just try to make my presentation in one shot. So if you don't understand anything, then please stop me and then I will try to go into the details. But for longer discussions or sharing experience or knowledge on tokens on consortium networks, I would propose the question and answers session. So let me start by tokenization, and I said it's a little bit like blockchain evolution. And surprisingly, I don't start with enterprise tokens, but I start just with the basic tokens, I would say. So the evolution looks somehow that way at the moment on the public area, that we got somehow Bitcoin, Ethereum, and then from Ethereum, I would say the evolution of blockchain somehow splits into two directions. One is somehow the infrastructure layer, and I would say it's something which is an infrastructure innovation. And there are many very interesting infrastructure innovation in both the public space and the consortium space as well. It's usually like layer 1 scaling or layer 2 scaling, or even something as just an answer. There's gonna be a record, and then it's on YouTube, and you will find the record actually on Hyperledger on the Hyperledger YouTube page. So it is recorded as far as I know at the moment, and live streamed as well. So back to the topic, we get something as an infrastructure innovation, which is very interesting and very challenging as well, including like layer 1 scaling, layer 2 scaling, and a lot of interesting stuffs as well. But what's perhaps more interesting, or less technical at least, that we got something as an innovation on the application side as well. And basically, one of the bases of this innovation on the application part is like defining basic building blocks for an applications that are basically the tokens. So I would say tokens or tokenization is something which is an application side innovation, and it's getting to be standardized. And this will be basically the basic building blocks of many different applications. But it's a conceptual layer, so it's not necessary, doesn't relate it very much to the infrastructure side. It's rather something which is a conceptual building blocks, how you can build up applications on top of blockchain. So this kind of innovation going a little bit to the application side. And the most famous example, of course, like NFT and DeFi, that's the public space. So for instance, NFTs, I would say it's like a little bit hyped at the moment, but if you take a look on like DeFi basically consists of many applications, and all of these applications are built up with the help of tokens. So we got something which is basically, from an abstraction layer over smart contract. So basically we get like token, the API is smart contract, but smart contract is almost like infrastructure, and token are almost like, conceptual building blocks, one layer above the smart contract realization. And basically applications like a DeFi are built up with the help of tokens. And of course, this is public blockchain. It's very much hyped at the moment. But it looks that way that so customers getting used to these tokens basically in the public space. So they're getting used to that. Hey, we got something as a fungible token, we got something as a non-fungible token, and it looks that way that basically as they already aware of these tokens, even at building up like very classical consortium blockchain applications, they want to use these tokens. So it means that tokenization at the enterprise blockchain scheme is not so much hyped at the moment, or not so much popular, but it's getting to be more and more popular. And again, so as basically customers getting used to having these concepts like different kind of tokens, they know what's the difference between like fungible and non-fungible tokens. They want to use basically the same tokens in enterprise ledgers as well, and in enterprise blockchain applications as well. So for these reasons, it's very much interesting to speak about like tokenization and how tokenization can be supported on consortium or enterprise blockchain applications as well. So there should be one arrow here, like tokenization, and there should be something here as consortium blockchain applications, and then token-based consortium applications, which still doesn't exist, but it's coming. So basically in the nearest future. So speak of tokenization, that's the basic roadmap. Usually we distribute like, depending of if you're very deep in blockchain or just a high level. If you're just a high level, we distinguish like 3 different major tokens. If you're very deep in blockchain, then you differentiate like, I don't know, 25 different kind of tokens. But let me just start with the 3 major ones. So basically we got like the 2 major categories are like fungible and non-fungible tokens. Fungible token is like, so basically you get a token and 2 tokens are practically identical. So practically they are the same. They can be used exactly in the same way, in same circumstances, and so on and so on. So fungible token is like money, is like currency. If you got like 10 euro notes, then one 10 euro note should be actually the same as another 10 euro note. So they shouldn't be different somehow. So it means that if you just tokenize like euro, coincidentally, with like CBDC or something similar, then basically one token, one fungible token should be actually the same as another one. So it means that like, I mean, these tokens are identical to one another. It's like the example use case is cryptocurrency, but it's in a public blockchain. But I mean, supposing that, CBDC reaches actually the production level, I would say that fungible token will be like of CBDC, for instance. The other category, let me just check if there's like a chat. Yeah, I mean, you can say that, but so I mean, as a usage, basically in all kind of yeah, like you can say that. I mean, it's physically, it's one paper is different from another one. But in all, I mean, tokenization is an abstraction basically. So in all usage situation, you use one 10 euro note as another one. So it's more or less the same. Yeah. You can say coins, but I mean, even if you say coins, you can say that, I mean, it's in a physical way. One physical token is different from another one because it's a different physical object. So, in this sense, fungible is basically an abstraction which might not exist purely in the physical world. But I mean, it's a good analogy just to imagine as a currency basically. I say cryptocurrency. I mean, you might as well discuss some cryptocurrencies are not totally fungible. So like Bitcoin is not totally fungible because I mean you can track actually the money and with like a transaction graph analysis, and in this sense it's not fully fungible. It's like Monero or Zcash are basically fungible cryptocurrencies. But again, it's just an abstraction, so it might not I mean fully 100% overall, but it's a good conceptual I mean framework differentiate tokens. So the other token is like NFT. It's a non-fungible token. The idea from non-fungible tokens that each token is different. So like one token is totally different from another one. It's again, it's an abstraction as well. But one of the example is like, let me just imagine we tokenize basically art. Like we tokenize the Mona Lisa and we tokenize like, for instance, Picasso. So in this sense, Picasso and Mona Lisa will be totally different tokens. So that's non-fungible tokens, and it's pretty much hyped at the moment. And we got like hybrid categories as well. So hybrid categories of tokens is something in between, which is partly fungible and partly non-fungible. So basically, in this category, we get like categories of tokens, and in the category itself, these tokens are fungible, so they are similar to each other, or they are identical to each other, and between the categories they are just totally different. One example for that is like if you tokenize a game, like a role-playing game, and where you have like assets, like swords and shields, for instance. These are two big categories of tokens, of assets, and basically in one categories, the tokens, the assets are the same. So you can say that like one sword is exactly the same as another one, and one shield is exactly the same as another one. But between the categories, it looks that way that you can't really exchange them. So one sword is not exactly the same as one shield, and one shield is definitely not the same as a sword, for instance. So that's like hybrid tokens. Let me just give some example. And these are some of the examples originated firstly in the public blockchain world. So for fungible tokens, we got like the cryptocurrencies. But again, you can say that, say, what about enterprise ledgers? If you don't like cryptocurrencies, then again, use just CBDCs. We can say stable cryptocurrency, that's pretty much the same. It's like platform tokens, like with Ethereum. It's still public, but like if we just, I mean, imagine like securities tokenized stocks or tokenized bonds. It's something which is a token, and you might as well imagine actually in like, in a public blockchain as well. There are already initiatives for that as well, but it's typically something which is relied on consortium ledgers between banks. Not quite sure if Hyperledger Fabric, but Hyperledger Fabric does this, for instance. But like there are certainly examples with Fabric and with like R3 Corda as well. So these are like tokens on enterprise ledgers representing kind of a security. And we get tokens again, more or less in public. We get some governance tokens and like tokens representing natural resources. These are all basically like public fungible examples. I just close basically this chat because I mean there are some questions that I would rather try to answer at the end of the presentation. Otherwise, let's just change topic too often. So let me have just examples for non-fungible tokens. Examples for non-fungible tokens is, for instance, like tokenization of physical art. It's like Mona Lisa and Picasso. It's very much hyped like tokenization of virtual art. It's mostly happening on public blockchains, but like, I mean, tokenizing the physical art can happen actually on a consortium ledger as well, like with different galleries and so on and so on. It's again very much hype, like the virtual reality games, especially like metaverse and stuff like that. So like, I mean, selling virtual properties or any kind of stuffs on these games. There are like virtual cards as tokens in different games, in different strategies games, like asset tokenization in role-playing games. So gaming is a very, very strong application. You can do something as physical property tokenization. It's not so much hyped because it's, I mean, practically it has some legal problems. So legally it's just not so easy to tokenize or perhaps partially tokenize basically like a house and then sell it. But like, for instance, one such a use case is, I would imagine, more like on a consortium ledger, basically. Then it's again a public blockchain, like tokenizing funds in DeFi protocols, and then like crypto collectibles. Again, that's mostly public use case. Nevertheless, so in NFT, there are some possible applications on consortium ledgers, and I'm sure there's going to be more in the future. So these are like example tokenization use cases. So going a little bit into the details. So we get, I said we have like three different kind of tokens, or if we want to go very deep into the details, we get like, I don't know, 30 or 40 different ones. So if you really want to take a look on the different token possibilities, I would say, one idea, and that's the most common way, is to take a look on token standards. And these standards are initiated by Ethereum. So they are like ERC, Ethereum change request, basically. That was somehow the original name. And basically, I mean, the whole world is getting used basically these concepts, even if it's not used in Ethereum, but somewhere else. So we usually say that like ERC20 is a fungible token, ERC 721 is an NFT token, ERC 1155 is a hybrid token. We usually say that even if they are not exactly on Ethereum, and even if they doesn't really look like exactly as the original standard propositions. It's important actually to look that basically in Ethereum there are like, I don't know, at least like 20 or 40 different, like ERC proposition. They are all related somehow to tokens. Nevertheless, it might not make sense to use all of them overall. So, I mean, it's practically a good idea to say like ERC20 is a token which has some functionalities. Anyway, standards basically describe the major functionalities of the token. That's practically the interface. And it might make sense like to use ERC20, not just with Ethereum, but overall, basically. There are some token standards in Ethereum, however, that are not necessarily the best idea to use somewhere else. So like ERC 223 is like an extension of ERC20 token that protects from like accidental transfer of Ether and of tokens, of ERC20 tokens as well. So it's a good question if it's such a standard that's possible to use somewhere else, or is it kind of a stuff which is very specific to Ethereum and shouldn't be actually very much considered like on other ledgers as well. There are like ERC 777. It's like you define operators to send and receive tokens. It's again a good question how much it is very much on focus on Ethereum and how much it is something which can be basically imagined somewhere else as well, like on a Hyperledger Fabric. I'm not quite sure if it would make sense actually on a Hyperledger Fabric, basically, such a thing. Again, ERC 1155 is a hybrid token. It definitely makes sense somehow on consortium ledgers and on enterprise ledgers as well. Perhaps not one-to-one, but just the major, major functionalities or major interface. There are some other things or other token standards that can be considered basically in like, enterprise or consortium ledgers. It's like ERC 1337 is basically something which is a recurring payment standard. It would make sense if there's really payment in your ledger, which might not be the case. But we got like standards for security token basics or security tokens, or even for SEC compliant security tokens. These tokens have like the functionalities for KYCs and stuff like that. So they are certainly something or such standards that could be considered basically on different ledgers as well. So one starting point to get tokens from somewhere to the enterprise and consortium world is just considering the ERC Ethereum token standards and taking a look if they are applicable to like enterprise or consortium ledgers as well. So that's the most common way. There might be another way as well, which is not very much used. It's pretty much like a niche product. It was a good initiative. For some reasons, it is not very much used. And that's the token taxonomy framework, more specifically. It's basically an attempt to define like ontology of tokens, like different tokens with different properties and different behaviors and attributes. And it's just a definition. So they try to do it somehow in a totally blockchain agnostic way. So again, it was a good initiative. It is not widely used. So I saw like, in like 20 white paper, you see like one where like token taxonomy is even considered basically. But nevertheless, it's an interesting idea. It looks basically that way. The token taxonomy framework has a kind of a calculus. Calculus is, like a syntax basically that looks mathematic. Even if it doesn't really have semantics behind or formal semantics. What you do basically is you can define like base types. It's like fungible and non-fungible tokens. You can define like behaviors or behavior groups. So like, transfer, for instance, or minting or stuff like that. And you can define properties on these tokens. And basically it looks that way. That your token definition is described somehow. Again, it looks to be a little bit like formal and mathematical. So you got like definition for like the base types. You got like behaviors. These are the behaviors. So like I'm not quite an expert of the syntax, but If you have like minting functionality, then that's kind of a behavior that can be seen here. And then you can have like properties as well, like, I don't know, in NFT, like if you have like a link to an external storage where basically your digital art is stored, that's kind of a property basically. Surprisingly, there are some platforms that start somehow to support this token taxonomy framework. So one thing that might worth looking is basically that's a Visual Studio extension, and in Visual Studio you can see, like, so if you just start Visual Studio and basically take a look on extensions, you find like 2 or 3 token taxonomy framework extension. This is one that installed. You can't do actually very much, but I mean you can get a feeling at least how it works. So you get like a lot of like token artifacts. So it's like this is like a fungible token. You get like fractional non-fungible token. It's like singleton, which is kind of an NFT, which is exactly one, and so on and so on. So get many basic types basically. You get like behaviors. So it's like burnable, and then clicking on burnable, you see exactly what burnable means. Like delegible, or delegable, divisible, I don't know, issuable or mintable. It's something that I know, and so on and so on and so on. And it looks that way. You can sure have a lot of other things as well. You have behavior groups as well, and you have like properties that are somehow separated into property sets. So like you have a couple of examples here, like properties related somehow to carbon emission, core carbon attributes, and stuffs like that. So the idea is somehow that you usually have a token designer as well. So if you just want to design a new token, I just start here a new token. I hope it's gonna work. It sometimes, crashes my Visual Studio, but basically you can somehow design your token in a way, with drag and drop. So like you want to have a token which is a fractional fungible token, whatever it means. So that's like your base token, and you can have some carbon emission properties on that. So we have carbon emission, and then we want to make sure that we can burn this token. Again, it's not working at the moment, but drag and drop sometimes crashes for me. It works. So this is burnable, and then we can have like, I don't know, which is the attribute basically that I know, that we have like holdable, indivisible, there's something as issuable or mintable perhaps, that we have some issuable. I hope it's gonna work. It's gonna work. So like this is a token definition, and then there's a formula as well. So this is the formula of your token definition. And again, so at the moment it's nothing more than basically kind of formalism, how you can describe tokens, or even build these tokens into hierarchies as well. But as far as I know, there are already examples for that based on this token definition, you can generate code. Like you can generate like Solidity code, for instance, and based on the token definition, you can really create your smart contract. So it's again an interesting initiative. It's not so much hyped. I hope it's gonna be further developed in the future. So that's basically token taxonomy framework. And let me see some examples how like Hyperledger or consortium ledger products support basically tokenization. And I have like 2 Hyperledger examples. The first one is the easiest. That's Hyperledger Besu, because Hyperledger Besu is basically a consortium Ethereum technology platform. So basically what you do is you build up consortium Ethereum networks with Hyperledger Besu. It's a client, it's an Ethereum client basically. Mostly for, consortium scenario, there's a possibility to run actually public networks on top as well. So Hyperledger Besu is easy. You just get your Solidity tokens, your Solidity token implementation, and basically you can use it one by one. So without any modification, it supports the most up-to-date Ethereum virtual machine. So you can basically run on Hyperledger Besu any kind of token, any kind of Ethereum token that you want. It's worth mentioning perhaps that Hyperledger Besu gives you like two ways of somehow further developing these tokens or adding like additional functionalities for these tokens. One is kind of an advanced privacy, and the second one is kind of an advanced authorization. So advanced privacy looks that way, that basically, in Ethereum, practically everybody gets the transaction. So every node can basically validate your transaction, but it's pretty much a privacy problem. It's pretty much a privacy concern. So what Besu introduced is like a privacy group. Privacy group looks that way, that only specific nodes in your Ethereum, usually consortium network, gets your transaction, and only special nodes validate your transaction. And basically, it looks that way that there's a public and a private state as well. So if you have a privacy group and not all of your nodes basically get the transaction, then the changes of your transaction are practically recorded just in a private state, so not in a public state. But again, it gives you kind of a privacy. As far as I know, there's two implementation. One makes sure, so one is a cryptographic implementation, and another one is a physical privacy. So in physical privacy, exactly the nodes that should get the transaction gets the transaction. I think it's like with an additional technology called Tessera, if I'm not mistaken. But again, it's a physical privacy. In a cryptographic privacy, all nodes get somehow your transaction, but it's an encrypted transaction, and only some of your nodes gets the possibility to decrypt it, basically. So that's something that you can consider. You can have your tokens on Hyperledger Besu. Again, just any kind of Solidity ERC, anything implementation, but you can consider to somehow enchant them with like advanced privacy scenarios or options. The second one is called kind of an advanced authorization. It looks that way that you can grant access for an account, for instance. And you can do it on several ways. You can do it on a node level. It doesn't bring much, basically, I would say, but you can do it in a totally decentralized way as well. So it means that there's a special governance smart contract running on your Hyperledger Besu consortium network, and you can grant access for specific accounts or deny access for specific accounts on that smart contract level. And basically, the smart contract is considered in the mining. It's not mining, it's validation, basically, but it's considered in the validation and the block creation. So practically, that means if you do not grant access for an account, then this in the smart contract, then this account, the transactions from this account will not be mined very very specifically. So that's another thing that you can consider with your basic tokens. So that was Hyperledger Besu, and of course, the big platform on Hyperledger, that's Hyperledger Fabric. So Hyperledger Fabric has many more than one possibilities for realizing like different tokens, and these are perhaps the most important possibilities. There are implementations for ERC20, ERC721, and ERC 1155. That's basically in Fabric samples. If I find Fabric samples, that's Fabric samples. Let me just bring it a little bit bigger. So you can find in Fabric samples, these are like a specific way of these tokens or specific implementation of these tokens in Hyperledger Fabric. I'm going to show at the end the ERC20. It's again not exactly the same as a Solidity ERC20 token because in principle the general idea of Hyperledger is different. I mean, the general structure and the idea behind is different from Ethereum, from Solidity. So for this reason, what you see here, ERC20 is not exactly absolutely the same as a Solidity ERC20, but I mean something pretty similar. And you find like 721 and 1155 as well. And yeah, basically this is a community project, so I mean other tokens might come as well. So that's one important thing in Hyperledger Fabric. And there's like two other initiatives as well that might be interesting in terms of tokenization. So first, Hyperledger Fabric is an account-based ledger, and account-based ledgers are not so easy sometimes in terms of privacy. But there are other ledgers as well. It's called the UTXO ledgers, the unspent transaction output based ledgers, like Bitcoin, that can be much better fine-tuned in terms of privacy. And the idea is something similar as by Zcash. So in Zcash, you use like a UTXO-based ledgers, and you get some advanced privacy constructs like zero-knowledge proof, and it gives you a pretty good privacy, basically. So for this reason, I mean, the same idea is initiated somehow on Hyperledger Fabric as well. So there's basically something as an UTXO ledger. You can find basically the token UTXO ledger as well. So there's an unspent transaction-based output kind of implementation or initiative of tokens as well in Hyperledger Fabric. And I mean, the developers try to bring somehow the same privacy guarantees to Hyperledger Fabric that is available in like not in Monero but like in Zcash. So mostly, I mean, Monero uses like ring signatures, but like in Zcash you get like zero knowledge proofs. So basically the same ideas are being developed here at the token UTXO model as well. So that's one interesting project, and there's another one interesting project as well. It's called the Token SDK. It looks that way, that there are the so-called Hyperledger Labs. And like, I'm not quite sure if I have that open, but I have it open. So Hyperledger Labs are like, small projects basically in Hyperledger. So not like big platforms, or still not big platforms. Perhaps they're going to be big platforms in the future. And there's one interesting lab, which is the Fabric Token SDK. This is the Fabric Token SDK. And Fabric Token SDK tries somehow the abstracts away the definition of a token from an exact implementation. So the guys try to do kind of a general framework where you can define and somehow, partly implement as well tokens as well, but as much as possible in an implementation agonistic way, or even in a blockchain agonistic way as well. So the idea is something similar, that you can define tokens for the first one for Hyperledger Fabric, but like you can define which are the privacy guarantees that should be available for your token, and then based on your privacy guarantees, it can be decided is it something which is deployed to a UTXO ledger, or you can use something which is a totally standard Hyperledger Fabric like ERC20 implementation. It's a modular architecture, so the idea is that on the long run you can define tokens, but these tokens are not only developed or deployed to like Hyperledger Fabric, but basically to some other blockchains as well. So it's like, as far as I know, there's there's already something as an atomic cross-chain swap or being developed atomic cross-chain swap. So it's tried to be some kind of general abstraction framework for tokens, but not just as token taxonomy framework, which is more like a rather theoretical and description thing. But basically, the idea is here that anything that you implement generally can be run basically directly on one or on several consortium blockchain ledgers. So that's token taxonomy. That's token SDK. It's a very interesting initiative. I was checking a little bit details about other Hyperledger labs or Hyperledger products as well, like Hyperledger Sawtooth or Hyperledger IROA. I didn't find much on tokenization regarding this project, so I'm not quite sure if they're doing. Perhaps there's some initiative, I just didn't find it. Nevertheless, they are not so much in a hype. So last but not least, one interesting idea, which is basically not Hyperledger, but it's an enterprise ledger. There's like token frameworks in R3 Corda as well. That's called the R3 Corda Token SDK. And I mean, actually, Corda has basically a totally different approach than most of the blockchain platforms. It's not even called blockchain. It's like a distributed ledger platform. And basically, the idea is here that so first, it's not decentralized, but you can define how much you want to centralize or decentralize your use case. Basically, UTX model working with contracts. So contracts in terms of real contracts and not necessarily smart contracts. And basically, the ledger is kind of an evolution of these contracts in a UTX model, basically. So they define, I mean, it's very much in a financial and banking specific stuff. So like an R3 Corda token is basically something which is an agreement. It is regarded as an agreement between an issuer and the holder. It's like a contract and not smart contract, but like almost like a legal contract between an issuer and the holder. And basically, this agreement is considered as a liability from the issuer, and it's considered as an asset to the holder, practically. So I mean, you can't live in R3 Corda without like double entry accounting. All of the concepts try to get this idea. So nevertheless, even in R3 Corda, you have the token SDK, you have something as fungible tokens, you get something as non-fungible tokens. As basically the Corda ledger is like the evolution of contract. You can have something as evolvable tokens, so that can really be modified or extended on the long run. And there are like non-evolvable tokens. It's like like an NFT that changes perhaps only the holder. That's like a non-evolvable token. And you get like workflows and processes as well. So first, like define, issue, move, redeem, or select different kind of tokens. Basically, in Corda ledger, in your logic, you can even define who should validate basically your contract or your transaction. So it's a little bit like more specific, more special, and a little bit like a little bit different ideas than general blockchain platforms. But nevertheless, you can find the token SDK in R3 Corda as well. So last but not least, I got some ideas for interoperability. So as basically there are many blockchains having like different tokens or different type of tokens. It might be an idea how they can be, I mean, work together, just interoperability. And then for blockchain interoperability, there are like two examples in terms of tokens, and the two major examples. One is like doing atomic cross-chain swap, and the second one is like something as a cross-chain token. This is from a theoretical point of view. You can find on the right side that's an atomic cross-chain swap. So it looks that way. You want to send one token on one ledger and another token on another ledger. So basically what you do not really send these tokens, but you initiate something as a hash time lock contract, which is basically a transaction which is not fully executed but only halfway executed, and then you initiate an HTS on another other ledger as well. So again, a halfway executed transaction, and basically you get something which is a hash lock and a hash key. So you initiate these halfway transactions, this HTS with the help of a hash lock, and supposing that you have the key, you can unlock this transaction with the key. And if you unlock one transaction with the key, your key will be visible on one blockchain, so the other transaction can be unlocked as well. That's the idea. And if you don't unlock these transactions, there's a timeout that expires, so they will be rolled back practically. That's like atomic cross-chain swap, very briefly. It's more complicated under the hood. And the second idea is in terms of blockchain cooperation and tokens, that's something which is a cross-chain token. And cross-chain token looks that way. We get like two blockchains, the two blockchains having like tokens. I mean, native token in one and native token in two. So what we do basically is we somehow lock one token or several tokens on one blockchain. We give basically a cryptographic proof that this token was locked to another blockchain somehow with the help of a smart contract or some other things. And as soon as it is proved that tokens on one chain is locked, we can mint a new token practically on another blockchain. It's like, the classical example is wrapped Bitcoin, where we practically lock Bitcoin somehow on the Bitcoin blockchain. And then as soon as this lock is proved, basically we mint one Bitcoin on the Ethereum network, which is basically a wrapped Bitcoin. And I mean, the other direction is pretty similar. So if you just, burn the token on one blockchain, then it can be unlocked on another one. So that's like cross-chain tokens. I mean, certainly implementing such things are not so easy. So there are some initiatives for general interoperability platforms between different ledgers, and especially between different enterprise ledgers. And two initiatives from Hyperledger. One is Hyperledger Cactus. That's a general modularized interoperability framework. It has, or it plans to have at least, I guess there's already some implementation as well, both for atomic cross-chain swaps and cross-chain tokens as well. Anyway, just one. So basically, I mean, if you want to do interoperability between blockchains in terms of tokens, it's not so easy necessarily, because I mean, what you have to pay attention that basically the double spending between two blockchains should be avoided as well. So it's a little bit like tricky, but like, I mean, these two mechanisms are basically capable of avoiding like double spending, even between ledgers as well. There's another initiative as well. It's a Hyperledger Weaver. That's a Hyperledger lab, and it has basically an interoperability toolkit as well. It's still a lab, not a full project, but it might be further developed in the future. So that's the presentation, and now I can show some demo. Or I would propose, let me just have like a 3 minutes break, and if there's like, very specific question that I can answer in 3 minutes. So there are many questions. So not quite sure if I should start answering the questions right now, or shall we have basically the demonstration and let me have that at the end. So I would say the following proposition: if anybody having like a very, in a 1 minute question or something, I'm happy to answer. Otherwise, for longer questions, I would propose first that I would show the demo, and then at the discussion session we can cover these topics. So anybody having a very, very brief, like 1 minute question? So there's one new message. Yeah, I mean, as far as I know, Besu is already deployed in production, even in public networks as well. So like if you go to public Ethereum nodes, then like 7% of the of all the Ethereum clients running on Hyperledger Besu. So yeah. So let me just take a look, and it's a good question how I can. So what I'm going to show is basically we have something as an ERC20 token that's in Hyperledger Fabric, and let me just show a demonstration on this ERC20 token. It looks that way. It's in Fabric samples. So let me just try to show the code. Basically, what you have is a folder with your ERC20 chain code, and there's a README as well. I would just try to start the first version of the README. Unfortunately, this is like Hyperledger Fabric. So doing anything with Hyperledger Fabric is always like, complicated. So first, I would just start my network. It looks that way, that if you go to this ERC20 token, then basically it works with the test network. You get in Fabric samples basically a test network as well. It's pretty well documented anyway. So if you can't follow me, you can follow basically the description. So there's something which is a test network. I start the test network. The test network looks that way, that basically we get like two organizations. They are with certificate authorities, so each organization having a certificate authority. There's a one node ordering service which has a certificate authority as well, and there's a CLI as well. So practically that's all. The second step is to deploy the smart contract. So what I'm gonna do, as I started the network, basically I have created a channel. So what I'm gonna do is that I will deploy this example to the channel. So that's the ERC20 token on the channel. I'm not quite sure if it's saying much, but yeah, it looks great. So basically, it's the deployment process. I don't know what's the best way of doing demo with Hyperledger Fabric. Until everything gets done and gets configured, it's always a little bit complicated. So certainly I got some parameters. It looks that way. So Fabric is basically a little bit different, like a Ethereum. So the idea looks that way, that we get like organizations, and then different organizations, might have different roles. Can do different things. So like in this ERC20 example, we get two organizations. We get two organizations as well in the test network demonstration as well. And we get organization one and organization two. And the organization one is like having the role like a central bank, so they can mint token. And organization two can transfer token, but organization two shouldn't have something as mint token or burn token. So that's something which doesn't really exist in an Ethereum implementation. But again, it's kind of Hyperledger Fabric specific version of ERC20. So what I have to do basically is that I need to register identities. Identities are Hyperledger Fabric are not the easiest to do because everything is done by public key infrastructure, and then we get like some certificate authorities issuing X509 certificates, and these are practically the identities. These are the users. So it's just not so easy as in Ethereum that, you know, I just generate a private key, a public key, and that so on. So what I basically did, I generated one identity, and that's gonna be in peer organization. And in peer organization, I would say that will be somewhere as users. So that will be basically here. We got organization 1 and we got organization 2. And in organization 1, I got users. I got one admin and one user, one that's generated automatically. And I just created a minter. So this user identity can mean practically token. That's the idea. I mean, any kind of user identity here in organization 1 can mean token, but I just created this one specifically that this one can create token. So that's the first step. Then what I should do basically, I should create a user on the second organization as well. So I have just a second window. It's again some setup. I have to create a new identity. This new identity will be the recipient practically. So I created a recipient identity. It's a little bit complicated. It's basically, it has two phases. One with registering with the certificating authority, and the second one is enrolling with the certificate authority. So basically, at the end of the day, what I'm having here in organization 2, there's a recipient identity as well, and I get all the, you know, I mean, certificates here, and this recipient will get practically the token. So having that, let me just mint some token. It's again thousands of parameters that I need to set. But as soon as they are set, I can issue basically one call, which is basically kind of a chain code invoke. And then what I'm gonna do is that I call one function, which means basically 5,000 token to the current user. I mean, I just set the current user basically with this, all of these parameters. But what I'm having here is that there's another chain code. I can ask how many tokens I have. There's a client account balance. Because it looks that way, that I mean the balance of requires basically an address, but the address is a little bit complicated to get here. So I get another function which is client account balance, which gets the balance of the current logged in user. I mean, it's not really logged in with the parameters that I set. Basically, I just referred to the X509 certificates that I created. So basically, that's the current user in a way. Just to make sure I don't cheat, let me just try to mint 5,000 more tokens, and let me just take a look if it's like 10,000. It looks great. It's like 10,000 tokens. So I got basically tokens. I minted it. So let me just do something as transferring these tokens. What I'm gonna do, I'm going to the second window. It's something which is set up, or I'm going to set up to organization 2. So this one is organization 2. It's a little bit like complicated, but I can get the client ID. No, it's for some reason doesn't work. Yeah, just a second. Set of parameters. Recipient. So I hope it's gonna work.
Te salut, domnule. Ce faci?
Something went wrong, but anyway, so you saw basically this was one transaction. So the invoke was working.
Și cum ți se pare? Crezi că o să așa de... Fii atent. Apropo, cred că putem... asta până o să vină și ceilalți, o să joine. Eu nu cred că o să fie chiar atât de greu de făcut wallet-ul ăsta. Deloc. Deci m-am uitat peste modulele alea de Ethereum. În special am luat Ethereum-ul ca și baseline, știi? Să mă uit, să văd exact cum se comportă, ce trebuie făcut și așa mai departe. Și...
Ok, awesome. Okay, so we got some technical issues. Basically,
așa, acum ar trebui să mă auzi, nu?
Again.
Super. Deci putem să tragem direct modulele care ne trebuie. Nu știu, cineva îmi tot dă mute. Și că host muted you. Și eu sunt.
Yeah, exactly.
Eu sunt hostul.
So, guys, if you be so kind, if it's not related to the meetup. Okay, awesome. Okay, so let's continue with some technical issues.
Acum devin muted, e ceva în neregulă, ori cu căștile mele, ori cu Meet-ul. Putem să facem pull direct de secțiuni din
please stop disrupting? That's not appropriate. We'll need to remove you from the call.
E fucked up ăsta al meu. Dumnezeule. Stai.
Okay. So let's try to continue. Basically, so we had some technical issues, but anyway, so at least one transaction was working. So you can see basically I can mint basically tokens to one ledger, to one account. So just then,
ai putea să adaugi chestia asta la notițe aici în GitHub. Da, pune-le acolo, Redmi, ca să le avem. Mai sunt?
All right. So just taking a little bit the code itself. So we got chain code. This chain code is in Go. So we get mint. We get the functions like transfer, burn. We get transfer from and stuff like that. This is transfer, and we get transfer from. What's perhaps interesting is the feature that I mentioned. So if you have mint, basically, the whole authentication works with the membership service provider IDs and the identity IDs. So if I mint, anybody who is in organization 1 can mint. So basically what I'm doing is that I'm checking what's the membership service provider ID. And if it's organization 1, then I can mint. Otherwise, I'm just not authorized to mint token. I don't go very much deep into the code, but basically another thing is it's again membership ID basically for burn. And then if you use something as transfer, then it looks that way that it works with the client identity. So if I just create, basically I created with the certificate authority a new identity, a new X509 certificate practically, then this identity gets basically the token. So that's the account, and then the whole code basically checks if that account having the necessary number of tokens, and then basically the tokens are transferred from one account, which is one client identity, to another one. So that's the major idea basically. And we get transfer balance of, we get some client account balance, which takes a look what's the practically logged in identity and stuff like that. So that's basically the code. And I would say, so that was basically the official part of my presentation, of my demo. It hardly worked, unfortunately, but that's the usual demo case. So I would say that's the end. And then I can take a look at time answer the question. So where did I stop? You can take attributes for fungible tokens. Yeah, so again, so this fungible and non-fungible stuff, that's like an abstraction. So it's a good question if there's really something which is fungible and really something which is totally non-fungible. We might argue actually, so you can take something as attributes as well, but I mean, if you distinguish attributes, basically it might not be really fungible actually. Interested more in chain code as its structure. So that was the demo. I can't go at the moment very much deeper. It would basically need something which is another meetup to prepare. As you see, then basically we are pretty much at the end of the presentation. Is digital art first practical use case of NFT? Yeah, I would say yes. I'm not quite sure. I think the first NFT was still actually on a Bitcoin network, and it might be. I'm not quite sure. I think it was virtual art. It was like in 2013 or 14, if I'm not mistaken. And the second one is basically like CryptoPunks, if I'm not mistaken. That's like the second use case. They are all like virtual arts. So as far as I know, yes, that's basically. Yeah, that's with NFT, an owner can only own one at. Yes, so I mean, you can own more than one NFT. That's the logic, basically. So you can own any number of NFTs that you want. Yeah, it's already answered. Sorry, let me just from a receipt of a ticket. So aside from digitization, how NFT differs from a receipt of a ticket? Yeah, I mean, it's a good question. I mean, it's the question, how do you consider ticket? So if you consider like a physical ticket, it differs pretty much from an NFT. Like, I mean, if I consider like a concert ticket, it might not be an NFT basically. I mean, there are like thousands of tickets for a concert that might be actually fungible in the category. So they are not so much NFT. And yeah, it's like a little bit like different questions. But yeah, basically you digitize kind of a poker jeton, I usually say, and that's what's running on a blockchain that can be sold, that can be traded, that can be used in any kind of practically block applications, and that are basically integrated with each other. So I'm not quite sure if I answered the question or something. What's the name of the extension? So the extension that we saw here is basically if you just go in and token designer, if you just look for token designer, token taxonomy framework, you will see like 3 designers, if I'm not mistaken. So these are the extensions. Yeah, exactly. So what I was using here is the IWA token designer. You get like 2 designer for Neo, which is a blockchain as well. So I didn't try it, and I'm not so much familiar with Neo, but it might happen that actually Neo manages to generate code directly with the help of like the token taxonomy framework. Yeah, it's already. So basically, this token taxonomy framework doesn't run on any kind of ledger for the first one. There are like code generators. Or the idea is using like a code generator, and then you just define your token framework model, generate code, and this generated code might be a solidity that you can run basically on like Ethereum compatible blockchains. State machines. So basically, this is not a state machine. I mean, if you take a look on this token designer, this is not a state machine itself. It's basically it's called a calculus. If you're familiar like with lambda calculus, it's something similar. It's a syntax with practically a non-formal semantics or something similar.
Hey, could you please read the questions? I came quite late and I don't see them in chat, so it would really help me to know what questions you are answering. Thanks.
Sure. I'm just browsing it a little bit, but so I'm just browsing the questions. Most of them are related to this token taxonomy frameworks. Most of them were related where this token taxonomy framework plugin is to be found. That's something I show. And there was one question if this token taxonomy framework is like a state machine. And for that, the answer is not at the moment, but basically it's rather like a calculus. So one question. Sorry. Yeah, I mean, we can do it that way. So just raise the question if you feel like. I'm just browsing the chat.
Yeah. So sorry, maybe I wasn't clear. So I came late, and Zoom doesn't show me the chat, and I see another person is also late. So we don't see the questions, and you just give answers, and I don't know what question you're answering. So it's a little confusing. Yeah, okay. If you could just read the question aloud, it would be before answering. It would be very helpful.
Yeah. So I was browsing like the questions and the answers a little bit. They were related mostly for this plugin for the token taxonomy. But sure, I mean, I will just read as soon as I find, which is a question and not an answer for another question, perhaps. So like here is one question: what is the significance of this ERC implementation in private network? How close they are to actual ERCs? And then so the answer is that they are not necessarily the same, but I mean, as you saw, basically they cover somehow the specifics of the underlying platform. So I mean, even in Hyperledger, as you saw, there are some specialties because like you should consider the organizations and the structure of your Hyperledger Fabric I mean network. But if you get something which is an even wider distributed ledger platform like R3 Corda, then it's getting more complicated or more further from the real ERC like standards. So like for instance in R3 Corda you don't call them ERC, you call them as fungible and non-fungible tokens. So they are a little bit further from the real ERC standards. And then what's the significance? Again, so basically this is the like that was the first slide from me, the beginning of my argument. It's very simple. I mean, if you build like applications for blockchain, then basically you want to use the basic building blocks, and the basic building blocks are the tokens, and that's fungible and non-fungible. And even if you use like consortium ledgers or enterprise ledgers, that's where you start having the basic blocks like supply chain, and then you get an asset moving on your supply chain. I mean, you will for the first round say that hey, that we have this asset as an NFT or as a hybrid NFT token, and then let me integrate some payments in a consortium ledger that's gonna be a fungible token, and then basically use tokens as a building blocks, basic building blocks of your application. So the Hyperledger Capital Markets Group also has a project called Neferti around tokens. That's good. That's very good. I didn't know it. It's very interesting. I'm not quite sure about FEP token. If it's ERC20, it's probably yes. It's. I think it's a very old thing. So it probably covers kind of a fungible token. So here's the answer to building FEP tokens was in favor of token solutions on top of Fabric and UTX token. Yeah, so I'm not so much familiar with FEP token to be absolutely honest for the questions. Yes, it was UTX. So one question is, I did not follow any of the ERC standards it was UTXO in the family similar to Fabric samples token, UTXO and SDK, but that's not a question, sorry. Is Hyperledger Besu already deployed in production? I answered the question. Can we have these instructions? Yes, so I can put everything actually into a GitHub repo. Like if you mean these instructions, basically, like running the demo, but it's not very complicated. So I would say if you just go to Fabric samples and then you read the manual, you can find the instructions here. So here are all the instructions. I just copied into like a notepad. So this is a little bit like description, but you get the first step is let me just start like Fabric test network. Let me start Fabric test network with this script. Let me register an identity. Let me set basically the Fabric parameters. Let me export. I mean, this is again a Fabric parameter. Let me register an identity. Let me enroll the identity and stuff like that. So if you just go to Fabric samples to the GitHub repo and take a look on token ERC20 and take a look on README, you can find all these instructions. Yeah. So I can't explain at the moment ERC 721 code in Hyperledger Fabric. I didn't take very much deep into the under the hood. It should be actually an NFT version, so you got like NFTs. That should be an integer, and then the ownership of this token practically should be changed. And probably, I mean, the ownership to an account means something that you get the account as basically something which is a client ID, and then on top you get some authorization practically based on organization. That should be the general idea. I didn't take a look very deeply the code actually. What is the TPS? I'm not quite sure if you see that here that transaction per second or what you mean exactly. That's a question. Okay. So there's one question: what language are you using to write a code, and how can I write it? So it looks that way. If we take a look the Hyperledger Fabric demo, then Hyperledger Fabric uses like 3 different languages for your chain code. So you can use like Go, you can use Java, and you can use Node.js. The code I show very briefly, that was a Go code. But basically it depends on your framework. So if you like, use like Hyperledger Besu, then you use Solidity probably. Okay. Transaction per second. Okay, so I finished basically the chat. So is there any questions? I mean, either in chat or basically, I mean, just live. So basically, if there's no more questions, then I would say that was my presentation. And yeah, half of my demo, it looks that way that, I mean, the demonstration is always difficult, but at least Mint was working as expected. This is it. Can you expand? So there's one question is, can you expand on the primary object hierarchy for a smart contract? I'm not quite sure what you mean. So you can use like inheritance or stuff like that to expand like the functionality. But I mean, what you have like in Hyperledger Fabric is basically, it's a demonstration. So it's not like necessarily an official code. So you can just extend it as you wish, basically. And then if you use like ERC20 tokens in Ethereum, what you need to be sure that you use like the standard interface for your ERC standard, and otherwise your implementation is totally up to you. Yeah. So yeah, again, that was basically the presentation for today. So I hope you get some new knowledge as well based on my presentation, and I hope that it wasn't very boring. So thank you very much for the attention, and then, well, I don't know, see you perhaps, see you as online somehow next month or in 2 months at the next Hyperledger meetup.
Thanks, Daniel.
Hi, Daniel. I'd like to have a question.
Wait, I have a question also.
Daniel, are you still there?
Hello.
Sorry, so I'm still here. Yeah, sure. Just go ahead.
Hi, Daniel. This is Victor. I'd like to ask you a question. You're talking about the use cases for the token in all this enterprise blockchain. Just check with you, what is a good use case for creating payment tokens for all this enterprise blockchain? Because in the sense that the example you've given us about in a supply chain, you use a token for payment, but end of the day, how can this token be used to convert to fiat for all this payment?
Yeah. So in terms of payment, my experience is that I mean you get public blockchain. On the public blockchain, you use practically cryptocurrency as payment. On a consortium or on an enterprise ledger, this use case is still not so much typical. Because in a consortium or enterprise ledger, the payment use cases are initiated by banks. So there are 2 famous or getting to be famous examples for payment. One is CBDC, that's central bank digital currency, for which you still don't find very much examples, live examples, but it's pretty much hyped at the moment. So I would say that's for consortium ledgers in terms of payments. One example, or one very exciting example in the future is going to be CBDC. And another one might be, again, initiated by a bank. That's something which is, it's called digitized commercial bank money, if I'm not mistaken. And it's, again, a use case which is not, not a cryptocurrency and still doesn't really exist, but it might come, or it might be coming in the future as a payment on really enterprise or consortium ledgers. So I would say these 2 things. But basically, if you have general application, and if crypto payment is okay for you, what you can do is that you like an enterprise or a consortium ledger for your supply chain practically, and you integrate with a cryptocurrency. It's gonna be another blockchain. So you need to have some kind of atomic cross-chain swap or cross-ledger integration, and your cryptocurrency gonna run on, I don't know, on Ethereum or on Bitcoin, for instance. Of course, it's a question if your use case accepts something which is a crypto payment.
Okay. Yep. Thanks.
I hope I answered the question. So I'm still here. If you have some other questions.
Yeah. Hello, Daniel.
Hi.
Hi, yeah, thank you. I was one that asked which programming language. You told me Go, Java, Node.js. Now, my concern is this. I'm a programmer, but I'm new to blockchain technology. Now, how is there a link that I can get so that I can start from the foundation? Because I major with C# mostly. So now I'm going into this aspect. So how can I is there a link to start the foundation for me? Because now I'm new to it, totally new to it. So that I wouldn't miss out. I would not double here and go there and come back again. I don't know what I'm doing. Please help out on that.
Yeah, that's a good point. So if you actually new in blockchain, it's the question is which platform you want to start with. So one option might be like Hyperledger Fabric, but I mean Fabric is not the easiest and not the most perhaps interesting platforms to start with blockchain because it's very technical. You have a lot of work setting up your infrastructure and stuff like that. So if you actually new with blockchain, I would propose to use Solidity as a language. It can even be used with Hyperledger Besu, for instance, so you can run in consortium network as well. And like one way of starting, programming with Solidity that makes fun is to use Crypto Zombies. Crypto Zombies is a game for Solidity programming. It really makes fun. Let me just try to find it, and I will just put it to the link. Crypto Zombies.
Okay.
Yeah, so this is actually the meetup session, so it's the informal session. So is there like any other questions?
Thank you.
So if there's no more questions, then again, thank you very much for your attention. And then, again, perhaps see you next time.
Thank you.
Bye, everyone.
Thank you.